Okay, on this test, um, number one, which of the following is a rational number? So remember, irrational, if it's irrational, right? You see dot, 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 non-terminating, non-repeating, okay? Or you see square root of an imperfect square, right? There's your two situations. So looking at these, you know pi is 3.14 dot, 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 right? So that's going to be irrational. You want a rational number. Square root of 6, if you take it in your calculator, right? Square root of 6, that's not a perfect square. You get 2.49 dot, dot, dot. Okay. So you get 2.449 dot, 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 right? Not a perfect not a perfect square. Now the square root of 196, you take it and hey, it's 14. Okay. And then you take the square root of 8. That's not a perfect square. You get 2.828 dot, dot, dot. 2.828 dot, dot, dot. So the only one that's a rational number is going to be C. Okay. Number two, square root of 64. Hey, square root of 64, the next lowest perfect square is square root of 66. Which number is it closest to? The next lowest perfect square is 64. The next highest perfect square is 81. Square root of 64 is 8. Square root of 81 is 9. It looks like it's closer to the 8, okay? So now if you take the square root of 66 in your calculator, you get 8.1, right? 8.1 is closer to 8.1 is closer to 8 than it is to 9, okay? So the closest thing you have here is 8. You could have used your calculator on that one if you weren't sure if your of your perfect squares, which you need to be, okay? All right, number 3, a lot of people had problems with number 3. All right, so whenever you have parentheses and an exponent outside the parentheses, it's like distribution. You have to multiply that exponent into the other exponents. This exponent right now, there's none written. This x right now has no exponent written. So this 6 has an exponent of 1. So does this x. Okay. So that -2 is 6 to the -2, right? Because -2 times 1. And then x to the -2. Okay. And then you have this 4x squared. A couple different ways you can look at this. Both of these terms have negative exponents, so you got to move them down. Okay. I can't simplify this yet. I can't evaluate this because it has a negative exponent. Okay, so both of these come down. What's left at the top? See, both of these are going to come down. What's left at the top? 1. 1 over 6 to the positive 2. And then you have the times 4. And then you have x to the positive 2 that was there. And then this x to the positive 2. 6 squared is 36. 36 times 4 is 144. Now you got x squared times x squared. You add the exponents, 2 plus 2. 2 plus 2 is 4. And then you still have the 1 left over. Okay, so this one was B. Okay, number 4, you could have done this just in the calculator. Okay, to do this by mathematically, right? For addition, subtraction, you need the same exponent in order to add and subtract. Okay, so if I make this, let's go ahead and just it actually doesn't matter which one you choose. Okay, I'm just gonna go ahead and do this one. Change this 10 to the 4th to a 10 squared. So I'm gonna change 10 to the 4th to a 10 squared. So I made this exponent smaller. So I need to make this number bigger. Okay, I made this exponent smaller by 2. I need to make this number bigger by 2 decimal places. Okay, so 1.24 becomes 124, right? I moved it 2 decimal places because I needed to make it bigger by 2 decimal places. So 124 times 10 squared. That's what I'm going to use now. Okay, now so 124 plus 6.2. I just need to line up my decimal places. So I'm going to add. I get 2. 4 plus 6 is 10. Carry the 1. I get 3 and then the 1. Okay, and then the exponent what I had was 10 squared. Okay, this is not scientific notation yet. I need to put the number right here for scientific notation. 1.302. I need to put the decimal right there for scientific notation. I made the number smaller by 2 decimal places. All right, I made this smaller. So the exponent has to get bigger by 2 times 10 to the 4th. If you do that in your calculator, right, for this one, you did in your calculator, you have to type it in exactly as you see it. 1.24, sorry, parentheses, 1.24 times 10. The power button, the exponent button, is this caret, right, to the 4th, plus 6.2, okay, times 10, there's the caret, squared, okay? Now it's exactly like how it looks on the paper, and you get 13,020, okay? So you know you're going to have to put this in scientific notation just from your choices, okay? So you know it's either going to be C or D. If I put the decimal place right there, I've moved it 1, 2, 3, 4 places. So it's 1.3 times 10, 1.302 times 10 to the 4th. You could have also checked this answer. 1.302 times 10 to the 4th power gives you that. Okay. All right. Let's go on to the next one. All right, so for this one, the y-intercept looks to be a positive 4. Okay, the y-intercept's a positive 4. So these are all y equals mx plus b equations. Okay, so y-intercept's a positive 4. This is negative 4 y-intercept. So I know it's not going to be b, and I know it's not going to be d. The slope, left to right, that line's going up. So the slope has to be positive. The only one with a positive slope is a. You could have also checked these equations in your calculator by going to the y equals function. There's the y equals button right there. And the right one, x plus 4, it's y equals. I type in x. The x button is right there. Okay, x plus 4. And I hit graph. Hey, it looks just like that graph, right? The other ones won't look like that graph. Number 6. Okay, so first, here's your equal sign. Okay, you got to deal with the parentheses. Negative 2 times x, negative 2x, negative 2 times negative 4, positive 8. Then you bring down the plus 3. There's your equal sign. Then you got negative x minus 1. Okay, combine like terms. I have a couple of like terms here. Negative 2x, 8 plus 3 is positive 11 equals negative x minus 1. I have x's on both sides of the equation now. Okay, so I'm going to add this 2x, add 2x. That's gone, so I have 11 equals negative 1 plus 2 is 1. 1x, bring down the minus 1. And then the last step, I got to get the x by itself. It's x minus 1, so I have to add 1 to both sides. So I get x equals 11 plus 1 is 12. Okay. All right. Number 7, x to the 3rd equals 216. Well, what multiplies by itself to give you 206? Multiplies by itself 3 times to give you 216. This one you just use the calculator. Let's test x as being 6. So 6 to the 3rd. If I do 6, there's the power button, 3. Okay, I get 216. Right? The power button again is that rooftop looking button, right? 6 exponent 3. 6 times 6 times 6. Right? 6 times 6 times 6. That gives you 216. So this one's just A. All right, number 8. All right, so use the graph to determine which of the following ordered pairs is a solution for the given functions. So there's these functions, these lines are graphed for you down here, okay? So there are those 2 lines graphed. All right, where's the solution? The solution's where the two lines cross. Okay, the two lines cross right there. The x value, right? The x value is 1. The x value comes first, 1, and then the y value is 1, 2, 3, 4. Right? The y value is 4. Okay, so it's 1, 4. Okay, for number 9. The thing about this one, we didn't see too many of these. Okay, but the thing with this one, number 9, is these two equations are exactly the same. Okay, and why I say that is, notice each of these coefficients and the constant, right? If I multiply this bottom equation by 2, if I multiply in there by 2, 2x, 2 times x is 2x, 2 times negative 3 is negative 6 minus 6y, 2 times 4, 2 times 4 is 8. Look, exactly like the top. Okay, so these two equations are exactly, these two lines are exactly the same. If you have two lines, right, so these lines now are same line. Okay, if you have two lines that are exactly the same, right, there's going to be infinitely many solutions. Okay, all right, number 10. Okay, so for this one, hey, remember f of x is the same thing as y. So all of these are y equals, right? These are all y equals mx plus b equations. Which equation is represented by the function below? Okay, well, first, to get the m, right, I just need to find change in y over the change in x. Okay, so let's not use the fractions. If you don't like fractions, don't use fractions. Let's use these 2 points right here, 3, 3, and 6, 4. So for my slope, I know it's going to be positive because as x is increasing, y is getting bigger. Okay, so what's the change in y? Because the slope is the change in y over the change in x. Okay, so change in y, 4 minus 3, right? 4 minus 3, right? This is just y. We can cross out the x if you want. Okay, f of x if you want. So m equals the change in y, 4 minus 3, over the change in x, 6 minus 3. 4 minus 3 is 1. 6 minus 3 is 3. Your slope has to be 1/3. The only option with a slope of 1/3 here is C, right? There's your 1/3 slope. The other option you could have done is go to your calculator. Anytime you have a table, you can go to list, right? Put X in your L1, right? 3, 4, 5, 6. L2, put your Y's, 7/3. So that's just 7 divide 3. Okay, this is just 8 divide 3. So I'm just typing in 8 divide 3, right? So just so you can see, I'm just hitting for 8/3 in that second one. I'm just hitting 8 divide 3, right? And it changes it to a decimal for me. But anyways, you're just gonna put in all the y's, and then once you have that, right? I didn't put in all the y's. I just want to show you remind you of the keystrokes. You hit second list, go to calc, and then you hit option 5, and it'll actually it'll give you that equation. Okay. All right, number 11. Okay, so for 11, compare the rates for the following of change for the functions represented below. Remember, rate just means the same thing as slope. Rate and slope mean the exact same thing. Okay, rate and slope mean the exact same thing. So, which statement about the rates of the change for function C and function D is true? So, glance through the rates. Function D is greater. Function C has a greater rate of change. D and C have the same rate of change. C and D has a positive. C has a positive rate of change, and D has a negative rate of change. So you just look at it just wants you to figure out what the rates are and which one's bigger. Okay. All right. So for this one, remember, this is the slope. Slope and rate are the same thing. Slope is change in y over the change in x. So for this one, choose any 2 points. Choose the smaller ones, right? Okay, there's 2 points right there. All right, so it looks like y 7, 3, 11 is getting bigger as x is getting bigger. Okay, change in y is 7 minus 3. 7 minus 3 is 4. Change in x, 2 minus 0. Right, you're counting by 2's there. So the rate is 4 divided by 2. 4 divided by 2 is 2. Okay, so the slope, the rate for this one is 2. All right, let's look at the rate for function d. Okay, so function d, let's go ahead and look right there. Okay, so it looks like there's a point, right? 2 and 1, and here's another point. Okay, so let's get our triangle. Looks like the rise is 2, the run is 1. Okay, so 2 over 1 is also just 2, right? All right, so so it looks like they have the exact same rate. Okay, so option C for that one. I just want to check. Yeah. Okay, so number 12, which set of ordered pairs represents a linear function? So for a linear function, the slope has to be the same all throughout. Okay, so you got to test the change in y or the change in x for all of these. Okay, but let's just test out a first. Okay, so for a, okay, I'm going to check option A here. Here's the x, here's a y. If you need to make a table out of it, go ahead and make a table out of it. 0, 1, and then 1, 5, and then 2, 9. Okay, so here the change in y is 4, change in x is 1, 4 over 1. Okay, there's your slope. Now the second any other point has to also have a slope of 4 over 1. So 5 to 9, hey, this is also 4. 2 to 1, this is also 1. So this is also 4 over 1. So it looks like these points, all the points have a slope of 4 over 1 all throughout. We know it's option A. Let's test one that's not the answer, okay? So any one of these. Let's just look at B. So for B, so this was option A. So for option B, you have x, y, 2, 0, 5, 5, negative 8, 0. Okay, so looks like here, this is 5 over 3. Okay, and then here you have 5 over, all right, 5 to negative 8. All right, that distance there, 5 to negative 8 is a distance of 13. Okay, and actually you had to go down, so that would be negative 13. Okay, so 5 over 3, 5 over 13, their slopes aren't the same all the way through. Right? So that's why option A, the slope is the same all the way through. Okay, so number 13, what happens to the graph of a line if the slope changes from -1 to 2? Okay, so you think about a slope of -1. Okay, so m equals -1. Okay, the slope's going down. Okay, for a slope of 2, it changes from -1 to a slope of 2. The slope 2 is absolute value of 2, right? The value of 2 is bigger than 1, so the slope's going to be steeper, and it's positive, so it's going to be going up. Okay, so you end up here. Okay, you end up at the slope is 2 because it changes from -1 to 2. Okay, so A says the graph will slant downward towards the right. So look at this one. Towards the right, this one's going up, right? Here's left and here's right. This one says the graph will slant downwards towards the right. No, towards the right, it's going up. Okay. Look at B. The graph will slant downwards towards the left instead of the right. So look, downwards towards the left. That's the one you want. Okay. Okay. And the graph will move up 3 spaces. No, it doesn't say anything about changing the y-intercept, and the graph will be less steep. 2 is actually more steep than 1, right? The number is bigger, so it's going to be steeper for this one. Okay, number 14. The graph shows the linear function for y equals 1/7 x. So see for this, for that equation, there's the graph for it. Okay. If the value of x is -7, what is the value of y in the function? So here's your x. Let's find x is -7. X is -7 is right there. Okay. And then on the line, -7, what's the y value right there on the line? The y value is a -1. Okay, so you could have just used the graph on that one. Okay. Number 15, if Katie is playing with a bouncy ball, the ball bounces off the ground 3 times before it rolls into the storm drain on the slide. Okay. Which of the graph best models the situation? So, here, look at these graphs. This line is where the ground is, right? Anything above it, right, is the meters above ground. Anything below it is the meters below ground. Okay. So it's like that for all of these. There's ground. That's 0 meters above or below the ground, right? That line right there. Okay. So you think about when a ball bounces, it bounces high first. This one looks like it was 1 meter, then it bounces. Then after that first bounce, the bounces get higher. Okay. That can't be, right? For B, it looks like it's bouncing high. And then when it bounces off the ground, it can't bounce below ground. It's not going to go through the ground and go 3 meters below ground and then go up above ground. Okay. So kind of same situation here. It can't go below ground when it's bouncing on the ground. Okay. So for D, okay, so it bounces, hits the ground. So when it hits the ground, it's 0 meters above ground. And then each bounce is just a little less high. So 3 bounces. And then that last bounce, it doesn't hit the ground. It kind of rolls down the drain. When it rolls down the drain, then it goes below ground. Okay. So that's why it goes below that line there. All right. Number 6. Ben and Jonathan are fishing and each caught fish at a constant rate throughout the day. The fish Ben caught is represented by the graph below the fish. I think that's mixed up actually. Ben is shown on the graph. Okay, actually that's right. Ben's shown on the graph. Jonathan is shown on the table. Okay, so who caught fish at a faster rate? Remember, faster. So faster, the bigger rate. And rate just means slope, right? So we're just trying to find slope here. It looks like the slope for Ben, let's put a point there. Let's make a triangle out of it. Okay. So it looks like the slope is 2/1. So he's catching 2 fish every 1 hour. Right? 2 fish every hour. Okay. And then for Jonathan, it looks like if I'm just looking at the first one, he's just catching 1 fish, right? Changing y there and the change in x there, right? This is x, this is y. Hey, so the slope, change in y over change in x, it's 1/1. Okay, and it actually gets even slower. If you look here, it gets 1/2. Okay, so here you got 1 fish every 2 hours. 1 fish every 2 hours. Okay, so either 1 fish every 2 hours, he's catching 2 fish every 1 hour. Okay, so Ben is catching fish at a faster rate. All right, so number 17, which ordered pair could be part of this function? Okay, so remember for function, no repeats in x. Okay, so 2, 3, 5. Okay, no repeats in x. Now, which one of these, if you add it to that relation, would be a function? Okay, 2, 3, 5, 4. Okay, if I threw 4, 11 in there, then the x's still wouldn't repeat. But if I threw a 5, 12 in there, then the 5s would repeat. If I threw a 2, 9 in there, the 2s would repeat. If I threw a 3, 10 in there, the 3s would repeat. Okay. Okay, number 18. All right, so for 18, this is a line. Okay. So for this line, the degree measure is 180. Okay. So if that entire line is 180, it's split by this line to make 2 angles. Okay. So 53, making this angle, plus whatever this angle should be 180, okay? So all I need to do is subtract 180 minus 53, okay? So for y, it'd be 180 minus 53, right? 180 minus 53, y should be 127, okay? The only option that's 127 for y here is D, right? And x is 28, 127. So the degrees in a triangle should add up to 180. Okay, so the degrees in a triangle should add up to 180. So let's just check that 28 here. 127 plus 25 is 152, right? So these two angles make up for 152 degrees. So if I subtract 180 minus 152, I get 28, right? So x should be 28 degrees, which it is right there. All right, so for number 19, what is the perimeter of the triangle? Okay, so I need to find the lengths and then add them up. So 1, 2, 3, 4, 5, 6. So this is 6. Okay, and let's go ahead and ignore this A, B, and C here, because the naming of the triangle doesn't matter to us right now. And then this side is 1, 2, 3, 4, 5, 6, 7, 8. That's 8. Hey, I have a right triangle here. Okay, so I'm looking for C. Okay, so this is A and this is B, right? So it's A squared plus B squared equals C squared. A is 6, so 6 squared plus B is 8. 8 squared equals C squared. 6 squared is 36. 8 squared is 64. 36 plus 64 is 100. Now I got to take the square root. C equals 10. Okay, so C equals 10. Now it wants the perimeter. So I have to add up all the sides. 6 plus 8 is 14. 14 plus 10 is 24. Okay. Okay, so for number 20, 20 isn't one that we've done yet. I'll quickly explain it. We'll see it in class hopefully soon. All right, so using the diagram, determine if the two given figures are congruent. And the statement can be used using the given diagram. Determine that the two given figures are congruent and the statement that can be used to prove their congruency. Okay, so the thing here is this. The orientation of, one thing I should say, for each of the ones at the bottom, okay, there's a little apostrophe. That is the image. I always think about the apostrophe looks like an eye, okay? So the eye is the final image, okay? The other thing is the pre-image. Oh, sorry. The other thing is the pre-image, okay? All of these have an eye. That's the image. The image is where it ends up. All right, so it looks like it goes down, okay? The orientation stayed the same. It wasn't rotated, okay? It wasn't flipped, okay? The orientation stayed the exact same. It just moved down. If the orientation stays the same, it's a translation, okay? So the only thing here is that the only one that says it's been translated, or there's two of them actually, but this one says it's translated, this one says it's translated, right? The orientation's the same, so it's been translated. So it's not this, it hasn't been rotated, and it has been reflected. Okay, those affect the orientation. So these have been translated, and it's been translated 6 units down. Okay, so it's B. All right, and then this one, so again, there's your little apostrophe. So that's how it ends up. Okay, the apostrophe one, the image, that's the final image. So it starts small, and then the image, right, ends up big. Okay, since it ends up, remember, multiplying by, okay, the center is right there at 0, 0. Okay, so it's not going to be either of these. Okay, so the center, you notice the center is right in the center of the coordinate plane. Okay, so and the scale factor is 5. The scale factor means from here to here it was multiplied by 5. This thing is 5 times as big as this. Okay, so this one is C. Okay, number 22, another one of these. So for this one, all right, so there's the image. So it has gotten smaller. Okay, so it's gotten smaller, and then it's also been reflected across the y-axis. Okay, since it's gotten smaller, the scale factor has to be less than 1. Okay, so notice scale factor of 3. No, that makes things bigger. The final image was smaller, right? So scale factor of 3, no. Scale factor of 2, no. The final image had to get smaller. Multiplying by a fraction makes things smaller. Okay, so it's one of these two. So it's not reflected about the x-axis. Notice the reflection is about the y-axis. Okay, so again, we haven't looked at these yet. Okay, but it's option D. Okay, all right, number 23. So the volume of the cone, I put it on the board. Volume equals 1/3 pi r squared h. The key thing here is it gives you the diameter. The diameter is the entire distance of a line that goes through the center of the circle. Okay, so the radius is just half of that. Okay, so the radius equals 8, right? This gives you the entire diameter. You just want half of that line, so 8. So you have 1/3 pi r squared h, and r is 8. So let me put that in. 8 squared times the height, right? The height is 21. Okay, so it says to use pi as 22/7. Okay, I'm just going to use 3, or 3.14. Okay, it doesn't matter. I think most of you are more familiar with 3.14. So you're going to hit 1 divided by 3 times 3.14. Okay, times 8 squared. Okay, times 21. Okay, and you get 1,406. The closest thing to that is 1,408, so it's D. Okay, number 24. Eighth grade teachers are very happy with when their students perform well on tests. If data were plotted in a scatter plot to represent the situation, which type of relationship would the two variables have? Well, looks like happiness level, or the independent variable looks to be the test scores, right? Test scores, and then the happiness level of the teachers. So as the test scores increase, the happiness level would also increase. So this would be a positive correlation. All right, for this one, Mr. Henderson was trying to figure out how many containers he would need to hold enough popcorn. So we're looking for volume, right? How much something holds in his whole class on math game day. Each cylindrical container has a radius of 6. All right, so the radius of 6 and a height of 18. Okay, so we're just going to plug into this. Okay, so you have pi r squared. R is 6, so 6 squared, and the height is 18 times 18. Okay, and notice in the answers, they don't multiply in the pi. They keep the pi there. Okay, so you're just going to multiply 3 squared times 18, 6 squared times 18. Okay, so 6 squared times 18, and that gives you 648. Okay, so you haven't multiplied the pi in yet, so volume equals 648, and then the pi is still there, and volume is always inches cubed. Okay, all right, number 26. Which scatter plot shows a negative correlation? So let's see if we drew a line of best fit, right? That looks like it's going up. This one looks like the negative right there. That looks like a blob, right? Can't really draw a line there. This one looks like a line going here and then a line going there, okay? So it looks like the negative correlation, okay, is B. 27, which function would best be used to describe the line of best fit for the following data? All right, so it looks like the y, for the y-intercept, it looks like it's about 100 here, right? If I drew a line of best fit through there. It looks like, so the y-intercept looks to be about 100. But look, for the y-intercept, for y equals mx plus b, right? The y-intercept's about 100, but look, the y units are in thousands, so that's 100,000. So it's one of these, okay? Not just 100, in thousands. So 100,000, right? And then the slope looks to be negative. Okay, so for your y equals mx plus b of that line of best fit, the slope needs to be a negative slope. Okay, number 28, which of these scatter plots would best be used to model a linear equation? So linear, which one of these looks like a line? The only one that looks really like a line, right? If I could draw a line of best fit through, is C. And then two more. Jordan took a survey of 20 students at his local high school, asking students about their GPA and SAT scores. He recorded his findings in a scatter plot shown below. Okay, so it looks like there is a correlation. It looks like it might be a weak correlation, but it might be something like that. Okay, using the data that contains, so there's the GPA, right, increases, going to the right, increases going up. What conclusions can we draw about the correlation between SAT scores and GPAs? So it looks like the line of best fit has a slope, a positive slope. Okay, so it should be as GPAs, as the cumulative GPA increases, the SAT scores increases. So both should be increasing together, or right, both should be increasing together. Okay, so this one would be A. And then the last one, 30, using the graph below, what does a positive relationship in the scatter plot tells us? So if it's a positive relationship, as the number of baseball cards increases, the price of the collection also increases. So again, both of these should be increasing. Okay. If it's a positive, as one thing increases, the other thing increases.